Good afternoon, my dear students. I'm just recording this in the case I have problems with the internet again. So in case with that, I wanted to have this video so you can watch the class for today. Let's get started with the first activity I have planned for today's class, which is really easy to work with. I need you to pay attention in the case for the boardwork I'm proposing. It's just something for reinforcing in the first place, and the second part of the class, I'm going to go to what we did in our previous class. I wanted to, for the goal for today, you're going to be able to recognize or to use some patterns or to identify some patterns from chemical reactions, right, to obtain valuable data. So in order to warm up you, the boardwork for today's class is this: how many atoms you have 100 grams of water? Okay, what you have to do that in the first place, as always, like I told you before, you have to please use this rule. Well, more than a rule, it's just a strategy you could use if you're trying to master it. If you already mastered this, then it's in you using the math rules and stuff like that. For this exercise, there's no chemical reaction. It's just a simple conversion there. So it says how many atoms. So how many atoms, right, in 500 grams of water. So basically what we're going to do is just moving the arrow from here, there, right? From 500 grams of water to atoms, right? To atoms, to the total number of atoms. So what are you going to do in the first place? You're going to get started to write what you've got there. So in the first place, you have 500 grams, it says grams of H2O, right? And then you must pass the 500 grams, as always, like I told you, to moles, right? So in the lower case, you should put grams of water in order to cancel up, because you're going to use, whenever you use conversion factors, you must use fractions. So in the first part, what you've got is 1 mole, right, of H2O. What is the mass of 1 mole of H2O? If you find the masses into the periodic table, 2 hydrogens, 1 gram per hydrogen, in total 2 grams, and oxygen is 16, in total 16 plus 2, 18, so 18 grams in 1 mole of water, right? 18 grams of H2O. And then at the end, what you're going to do is just, in this moment, you just passed, right? In this moment, what I did is just passing from, right? I'm going to use another color because I prefer to use another color. Okay, this one, I just moved from grams to moles, right? If you got it, it will be checked, grams to moles. But I didn't want it to moles. The question says the number of atoms. Oh, for making the number of atoms, we have to do a step before. So we have to go there to what it says. It says before, also again, 1 mole of H2O. In 1 mole of H2O specifically, you have this 6.02 times 10 to the 23 molecules of H2O, right? Got it? So in 1 mole, 6.02 times 10 to the 23 molecules of H2O, which is really interesting to work with. And then you do the conversion and so on, so on, so on. Okay. Okay, so, and then again, you cancel out moles of H2O with moles of H2O, and now you have transformed the grams of H2O to molecules of H2O. Once again, the question wasn't about the molecules, it is about a specific number of atoms. So let's count, let's go to the other part again. And also you know that in 1 molecule, right, of H2O, which is one molecule of H2O, has specifically how many atoms in 1 single molecule? Well, if you get to count, let's see. H2O, it says you have 2 hydrogens and 1 oxygen. 2 hydrogens and 1 oxygen. You see, 2 hydrogens and 1 oxygen in total. In 1 single molecule, you're going to have 3 atoms, right? 3 atoms, right? And that's it, right? If you get to work in that, and then you just get to write and close your conversion factor, and after that just get to write it with equals, again to write that. Then you insert those values into the calculator, right? Into the calculator, and you get to write the following. You type as follows. Remember, conversion factors are fractions. So you get to write 500 times 0.02 times 10 to the, I'm sorry, I'm missing here, the 23. Yes, forgot to put that, sorry. Okay, once again, 500 times 6.02 times 10 to the 23, right? And times 3. And all of that divided to 18, right? It's going to give you specifically 5.01, right? 7, I am using 3 decimals, times 10, right? To the 25 atoms. Since it's not specifying which atoms of hydrogen, atoms of oxygen, that's why I put 3, right? In total, it's just atoms, and that would make it. Is that okay, my dears? So that was the first activity I wanted you to do, support work if you couldn't do it. So you're going to use it for reinforcing this stuff and working into that, okay? So to do this, and then I am going to